welcome to another mathematics video. In today's video, we're going to be doing the St. John's Grade 10 Mathematics June exam from 2019. This exam paper covers 12 questions, and in this video, we're only going to cover question 1 to 4, and the other questions are going to be covered in separate videos. So, question 1 asks us to indicate whether the following numbers are rational or irrational. Remember that rational numbers can be written as fractions. Let's make this pen a little bit bigger. So rational numbers can be written as fractions. But irrational numbers can't be written as fractions, right? So examples of irrational numbers include numbers like pi, what don't have a set pattern. So pi is 3.141519, da 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 da. But there's no recurring pattern. Whereas rational numbers are whole numbers like 1, fractions like 1 over 2, numbers that have recurring decimals like 0.131313, etc. So all of these numbers can be rewritten as a fraction. 1 can be written as a fraction, that's just 1 over 1. 1 over 2 is already a fraction. 0.133 as a fraction can be written as 13 over 100, right? So that's what we have to get clear first. What's the difference between rational and irrational numbers? So we're going to apply the same logic to the numbers that we've been presented with in this question. So 1.1.1 is 0, comma 8 with a dot at the top. That 0, comma 8 with the dot at the top means this is 0.8888, and the 8s continue till infinity. And so since there's a set pattern and 0.8 can be written as a fraction as 8 over 10, this number is definitely rational. And the symbol we use for rational is Q. The symbol for irrational is Q with an apostrophe or a prime, Q prime. So 0.8 recurring, this dot means that the numbers are recurring, repeating again and again until infinity, is rational. So 2 and 1/6. So this is 2 and 1/6. 2 and 1/6, already we can see a fraction here. So we know immediately that this number is rational. Now 2 pi is the same thing as 2 times pi. And earlier on, we spoke about how pi is 3.141519. If we multiply this by 2, it's just going to be 6.282, yada, 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 yada. But there still won't be any sort of pattern. So 2 pi is irrational because that pattern doesn't exist. And you can't write pi as a fraction. What about negative square root 3? Well, negative square root 3 is just going to give us the negative of whatever the answer for square root 3 is. It should be about 1.7 something. So there isn't a recurring pattern because 3 isn't a perfect square. Perfect squares are numbers like 2, 4, 9, 16, and 25, etc., 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 like we learnt about in grade 8 and 9. So the negative of a square root of an imperfect square is just going to give us an irrational number. So 0.8, rational, 2 and a sixth, rational, 2 pi, irrational, and negative square root 3 is going to give us an irrational number as well. Let's take a look quickly at what we'd get if this was the square root of negative 3. We know that we can't get the square root of negative numbers because those numbers are not real. But this is something you need to be aware of. The square root of a negative number is not real, but the negative of a square root gives you an irrational number. Let's try out question 1.2 then. 1.2 asks us to arrange the following numbers in descending order. So descending means from biggest to smallest. These numbers are all surds, so they're all under square roots, but they have different exponents. So we have the square root of 3, we have the cube root of 2, we have the fourth root of 2, as well as the square root of 2. Now here, we need to remember our laws when it comes to surds. So what would the biggest number be here? Well, it's pretty easy actually. So we start off from the number that is going to be the biggest under the square root, which is 3. So we'd have square root 3 as our first number. That's going to be the biggest number, right? The square root of the biggest number under the square root is going to be the largest number in the order. Next, we have all these number 2's under a square root. Now, we're going to arrange them in the order of the least exponents. So next up, we'd have the square root of 2. And then we'd have the cube root of 2. And we'd have the fourth root of 2. So first we start off with the biggest number under the exponent. Then we go to the smallest exponent. So the exponent here is 2, 3, and 4. So our descending order arrangement is cube root 3, cube root 2, square root of 3, square root of 2, cube root of 2, as well as the fourth root of 2. Next, we're asked to represent x as an element of -3, not included, to 6 in set builder notation and on a number line. So what's set builder notation? Most of us know what a number line is. A number line would look a little something like this. We'd start off at -3. We'd end up at +6. And to show that +6 is included, we'd close our circle. Let's maybe make that a different color so it's clear. You'd have a circle that's filled in, but because -3 is not included from the round bracket, we'd have an open circle at -3. What about set builder notation? So set builder notation just means using curly brackets. So what that would look like is we'd have x is an element from -3. X needs to be greater than -3 since it's not included, but it must be less than or equal to, since it's included, to 6. And very importantly, we need to express that x is an element of real numbers. And that's it. Let's move on then to question 2. Question 2 is all about sequences and series. Let's get rid of all of this stuff first. Question 2.1. Given the sequence 17, 26, and 35, give the next two terms of the sequence. How would we do this? Well, we'd have to look for a common difference between the numbers we've been given in the sequence. So, from 17 to get to 26, we need to add 9. From 26 to 35, we need to add 9. So if we need to find the next two terms of the sequence, we need to take 35 plus 9, and that gives us 44. Now 44 plus 9 is going to give us 53. We're asked then to calculate the 25th term of the sequence. So we need to use the formula for finding the term of a sequence. Let's use a black pen for this. The formula we know is Tn is equal to A plus n minus 1, close your bracket, times D. We know that A is the first term of our sequence, which is 17. So Tn is equal to 17 plus n minus 1 times our difference we know is 9. Now we're going to multiply our difference into this bracket. So we've got 17 plus 9 times n is 9n. 9 times negative 1 is going to give us minus 9. Therefore, if we simplify this, 17 minus 9 gives us 8. So Tn is equal to 9n plus 8. So that's our general formula for this sequence. So the nth term is 9 times n plus 8. So term number 25 would be 9 times 25 plus 8. And if you plug that into your calculator, your final answer will be 233. So 25th term of the sequence is 233. 233. Here's a theoretical question. 2.2.1 asks, is a sequence increasing or decreasing if the common difference is a negative? Let's look at the sequence we were given up here. Our common difference here was a positive. And when your common difference is a positive, it means that you're adding numbers, and so the numbers will be increasing, or your sequence will be increasing. So if your common difference is a negative, that means you're subtracting from your previous numbers. And so that means that your sequence will be a decreasing sequence. 2.2.2 asks us, which of the following gives us a decreasing sequence? Now, the previous question gave us a bit of a clue when it comes to this. Here we have Tn is equal to negative 2n plus 4, or Tn is equal to 2n minus 27. Here we have a negative difference. So negative 2n plus 4 is our decreasing sequence. Remember that the number before the n represents the difference. Now, on to question 2.3. We're given the sequence 16, 8, 4, and 2, and we're asked to find the nth term. Now, if we look carefully, 16 to 8 is minus 8. Minus 8 to get to 4 is minus 4. Minus 4 to get to 2 is minus 2. So we don't have a common difference in the beginning. But we do have a second common difference. So to get from minus 8 to minus 4, we need to add 4. To get from minus 4 to minus 2, we need to add 2. So now it shows that we're not going to use the formula that we'd used up here before. Tn is equal to a plus n minus 1. Instead, we're going to use the formula Tn is equal to a times r to the power of n minus 1. A, remember, is our first term. So the first term in our sequence was 16. So 16, what? Let's maybe write that 6 properly. 16 times r. R is our ratio, and we can find this by taking term 2, dividing it by term 1. So term 2, this is term 2, this is term 1. 8 divided by 16 gives us a half. And to show that this is true for the entire sequence, if we took term 3 and divided it by term 2, it should also give us a half. 4 over 8, we know, is still a half. So our ratio, r, is a half. So Tn is equal to 16 times r, which is a half, to the power of n minus 1. And that's it. You found the value for the nth term. If you wanted to simplify this even further, you could rewrite this as Tn is equal to 2 to the power of negative n plus 5 by turning the 2 into 2 to the power of negative 1 and distributing the exponent of n minus 1. But even leaving it right here is fine. Question 2.4. Here we're asked to determine the value of p in the arithmetic sequence below. So an arithmetic sequence we know has a common difference, d. So negative 27 is our first term. We've got p, and we've got negative 34. Let's think about this for a little bit. In order to get to p, we need to add 27. Or in order to get to negative 27, we need to subtract minus 27. And in order to move from p to negative 43, we need to subtract p. So we can create an equation. P minus negative 27 is equal to negative 43 minus p. A negative times a negative is a positive, so p plus 27 is equal to negative 43 minus p. If we take the 27 to the other side and bring the negative p to the left-hand side, we're left with 2p is equal to negative 70. If we divide both sides by 2, we find that p is equal to negative 35. And negative 35 is right in between negative 27 and negative 43. So we can be confident that our answer is right. Question 2.5. A program for preparing runners for the Comrades Marathon suggests running 12 kilometers in the first week of training and increasing this distance by 4 kilometers each week for the next 25 weeks. So let's highlight the important information here. So the program suggests we run 12 kilometers in the first week, and each week we increase our distance by 4 kilometers. And all of this needs to happen for a total of 25 weeks. So we're going to start off at 12. And for the next week, we're going to have 12 plus 4, which we know is 16. So that's 16. And we're going to add another 4 kilometers, which is going to be 20. And 24, etc., until we get to 25 weeks. So this is 1 week, this is 2 weeks, this is 3 weeks, this is 4 weeks. Now, we're asked to determine the formula to determine the distance run in any one of the weeks in training. So how are we going to find the general formula of Tn? Let's get rid of this. Now, remember, in the first week, we're going to be running, or we're suggested to run for 12 kilometers, 16, 20, then 24. So we're going to use the formula for an arithmetic series or sequence, which is Tn is equal to A plus n minus 1 times D. A is our first term in the sequence, which is 12. So that's 12 plus n minus 1 remains as it is, and our difference we know is 4. We were told that in the question. So there's a difference of 4 kilometers each week in the training program. So this is 12 plus, we're going to distribute the 4 into the brackets. 4 times n gives us 4n, minus 1 times 4 gives us negative 4. 12 minus 4 gives us 8. So Tn is 4n plus 8. And that's our formula for determining the distance on any week. 2.5.2 asks, determine the week in which 92 kilometers should be run. So what we're going to do is use the formula that we've just made. And we're going to look for n, which is the number of kilometers. So 4n plus 8 must give us an output or total kilometers of 92 kilometers. So if we take the 8 to the other side, subtract 8 on both sides, we're left with 4n is equal to 84. If we divide both sides by 4, we're left with n is equal to 21. So 92 kilometers needs to be run on the 21st week. 2.5.3 asks us, by how far will the distance run in the 10th week of training exceed 42.2 kilometers, which is the distance of a standard marathon? So what we need to do is we need to substitute 10 into our formula. Remember, our formula is 4n plus 8. So what we need to do is take 4 times 10 and find out 4 times 10 plus 8 and find out how many more kilometers will be ran in the 10th week that exceed 42.2. So how many kilometers will be ran in the 10th week? 4 times 10 gives us 40 plus 8 gives us 48. So now it's just a matter of subtracting 42.2, which leaves us with 5.8 kilometers. So the distance run in the 10th week will exceed 42.2 kilometers by 5.8 kilometers. Now we can move on to question 3, factorizing. Let's paste this over here so we can have a little bit more space. So question 3.1 asks us to factorize a to the power of 5 minus 4a cubed times b to the power of 4. So we'd take out a common factor of a to the power of 3, and that would be multiplied by a plus 2b times a minus 2b. Straightforward one there. 3.2, we have 27a cubed plus 8b cubed. We'd have two brackets. With our first bracket, we'd have 3a plus 2b. And in our second bracket, we'd have 9a squared minus 6ab plus 4b squared. And for 3.3, we have 2xy minus 6ab minus 3ay plus 4bx. So first we're going to start off by grouping these numbers together. So let's have 2xy and 4bx in a group minus 6ab, that would be 6ab, and we'd have minus 3ay. So here we're grouping x's together, and here we're grouping the a's together. Now we're going to remove a common factor, 2x multiplied by y plus 2x to get to 4. Bx would be 2b. 2b minus common factor here again, we'd have 3a. 3a times 6ab would be just times 2b, plus to get to 3ay, we just have a y. And then we can simplify this as 2x minus 3a times y plus 2b is the same as 2b plus y. So this is just one bracket, 2b plus y. And that's it for question 3. Let's take a look at question 4, where we're asked to simplify the following numbers. 1 plus 2 over a, and another one in 2.1.1. So 1 plus 2 over a is very simply just going to be a plus 2 over a. Four point 1.2 is a little bit more complicated. We have 2a plus 4 divided by, or 2a plus 4 over a squared minus 4 divided by 3a minus 6, everything over a squared minus 4a plus 4. So what we're going to do is we're going to apply the rule of multiplying by the reciprocal. So we'll be left with 2 times a plus 2 over, if we go back to, we know this is the difference of 2 squares. And we can factor out 2 as a common factor here. That's why we're writing it out as 2 times a plus 2. So if we write out the difference of 2 squares, that just gives us a plus 2 and a minus 2. Now we're going to multiply by the reciprocal, which means the denominator is going to come to the top and the numerator will go to the bottom. So our numerator here is 3a minus 6. So this is going to go to the bottom as 3 times a minus 2 if we take out a common factor of 3. And a squared minus a plus 4 can be factorized as a minus 2 times a minus 2. Now, we're going to have some brackets that cancel out. For example, a plus 2 and a plus 2 will cancel out. A minus 2 and a minus 2 will cancel out. And what we're left with then is just 2. Oh, and through cross multiplication, this a minus 2 bracket and that a minus 2 will cancel each other out. And on the left-hand side, we're just left with 2. And on the right-hand side, we're left with 3. But since these are multiplied together, we're left with 2 over 3 from cross multiplication. So our final answer is 2 over 3. 4.2. If x is p plus q over p minus q and y is p minus q over p plus q, determine the following in terms of p and q. 3 times x minus y. So this is a bit of a mouthful. Let's start off by substituting. We're going to have 3 times x, which is p plus q over p minus q. Don't close our bracket yet. Minus y, which is p minus q over p plus q. Now we need to get a common denominator. And our common denominator, our lowest common denominator, is going to be p minus q times p plus q. So that means that we're going to have to multiply p plus q by p plus q and p minus q by p plus q. So p plus q is going to give us p plus q squared, p plus q times p plus q. And this is going to be minus p minus q times p minus q gives us p minus q squared. And all of this is multiplied by 3. Next, we're going to square the binomials. To square a binomial, you take the square of the first number. So this is going to give us p squared, 2 times the sum of the two terms. So p times q is pq times 2 is plus 2pq plus q squared. Minus, we can open a bracket. P times p is p squared. P times negative q is negative pq. So this is going to be minus 2pq. And negative q squared is just positive q squared. I'm going to close that bracket, close that over there. And we can leave our denominator as it is for now, as p minus q times p plus q. Now we need to distribute this negative into the bracket. And we're left with 3 times p squared plus 2pq plus q squared minus p squared plus 2pq minus q squared. Everything divided by LCD p minus q times p plus q. Now p squared minus p squared will cancel each other out. Q squared minus q squared cancel each other out. And we're left with 2pq plus 2pq, all of that multiplied by 3. So 2pq plus 2pq is going to give us 4pq. And if we FOIL Our brackets at the bottom, p times p gives us p squared, p times q gives us positive pq, minus q times p gives us negative pq. So these two will cancel each other out. Minus q times q gives us q squared. So here we go to our final answer. That's going to be 3 times 4pq over p squared plus q squared. Oh, this is supposed to be minus q squared because it's minus q times q. So that gives us minus q squared. So this is, remember 3 can be written as 3 over 1. So 3 times 4 pq gives us 12 pq. And 1 times p squared minus q squared is just p squared minus q squared. And that's our final answer.